Welcome to Section 8, STFS Security. In this section, we will take a look at Linux ACLs, STFS security, Hadoop security, Hadoop users, and groups. Welcome to our section on security. In this section, we'll be looking at Linux ACLs, which will be a very important part of configuring or hardening the OS. So we'll be looking at Linux permissions in general. We will look at ACLs, which is access control list, and we will look at some of the pre-checks which we need to have for ACLs to be active, and then we'll look at some of the examples. So Linux security concepts. If you look at Linux security, there are a lot of things. For example, there will be OS hardening. It's a very vast topic. For example, there could be hardening in terms of patching, updates, rootkit detection, file changes, like let's say you might have a snort, intrusion detection, logs, right? Or SC Linux, IP tables. But our talk is very much limited to file permissions. In Linux, we have file permissions which are defined by 9 bits, or we can say groupings of 3 each. We can have, let's say, a user. The first 3 are user, then the next 3 for group, and the last 3 for others. In addition to that, we also have one more bit which is specifying the file type, whether it's a directory, file, any block device, or any character device. So before we look into the ACLs, it's very important to make sure whether our operating system has the right modules or packages installed, and does it support ACL or not. One is the kernel check, whether the kernel supports ACL, whether I have the required packages, and I have to check whether the file system which is mounted has been mounted with ACL support or not. Right? So some file systems might not have support for extended file system attributes. So let's check these things. So first thing, we will be doing a grep of ACL in boot config. Let's check that. So I'm logged into one of my nodes, which is my name node, which we have used throughout our course. I will be doing a grep -i ACL, and I will be doing on boot, and I will be saying config. I can just do a asterisk here. So I can see, my kernel has been booted with a lot of ACL supports for ext3, ext4, ZFS, BTRFS, right? NFS, right? CIFS, right? A lot of file systems. Other thing which I need to do is I need to check the support for my file system. So let's say I take this. So I have a lot of mount points. So let me show you the mount points. If I do mount, you can see I have few mount points, STA, for example. So let's check whether my mounted file system supports ACL or not. You can see default mount options, it has ACL in that. So if it is not there, I can remount this with an ACL option. I can say mount -o remount, which is a kind of a cyclic mount with an option ACL. If there are no packages, for example, if yum install I am on CentOS ACL, I can install that package if that package is missing from my operating system stack. Or I can install libacl as well. So I will say yes. So it's saying updating, right? It's not that my packages were not installed. It has found a latest update, so it's saying yes. So for the time being, just to say one time, I will not be updating, but you have to check those ACL and libacls are there. Otherwise, you will not see the ACLs enabled for your mount options. So now let's go back and let's look at some of the Linux ACLs. So by default, as we looked at, each file or a directory will have certain permissions, like for a user or a group or others. So the minimum access control list is same as that defined by file permissions. So for example, let's go back on a Linux system and check that. Let's see what file I have here. Let's say I have a file, Anaconda file. So let's say I do get FACL on this file. So you can see the get FACL, if I do on this by default, it is same as what my permissions are. So dot here means it supports FACL. Now you can see read write. It has the same one by default. I can change this behavior. I can get FACL, I can set FACL, right? I can say a default. On others will be read-write. I can say that the default FACL on others should be read and execute. I can say set FACL user Aman read-write on a particular file. I can clear a particular ACL by giving hex option, or I can give -b on that and it will remove all ACLs on that file. What does it mean? So let me take one of the examples here. Let's take this example and go back to the system. So what we do, I say Anaconda. So I'm saying set FACL default on the other one should be read execute, right? Execute doesn't make sense on CFG. Let's say read. I think the M because I've copied from my PPT. So important thing to keep in mind is only directories can have default FACLs. Let me pick one of the directories. So let's say I say downloads, or let's take a music directory. Get FACL and I give a directory. So you look at that. So it's exactly same as what my permissions are. I can set that on music. So now let's fetch it again. So now you can see it has changed. It was read execute, but it is now read. Similarly, I can give it for particular user. I can give it for a group by option G. So why we need it? Now the question comes, why we need ACLs? So let's say I have two users, user 1 and user 2. They both are part of the same group. But I want to control that a particular user can see only certain data, although he might be a part of the same group as user 2. So let's say I create two users, user 1, user 2. So let me just go to the system. We will create two users, user 1 and user 2. And then we will add that users to the sales group. And then we will assign certain permissions to it. And then we will see how it behaves. So let's go into one of the systems. I'm using the same master node. So what I'm saying, let's say user add user 1. I'm saying user add user 2. Then let's say I add group. Let's say sales. And then I'm saying user mod. I'm modifying the user. I'm saying, okay, secondary group, give it sales for user 1 and also user 2. So if I do ID user 1, you can see both users are part of sales group. Let's create a directory, projects, and I'm giving ownership of that directory to a particular user. Let's say user 1. So now I do get FACL on projects. So you can see the user has read write execute, group has read execute, others have read execute, and the owner is user 1. Now what we'll do is we will switch as user 1. I'll switch as user 1 just to make sure. Let me show you ID. I'm logged in as user 1. I will change to projects directory of which the user is owner. I will create an mkdir. Let's create a directory example, and I will say set FACL. Let's say -m. I'm saying user, let's say user 1 can do read, write, execute on example. But let's say user 2 can only do, let's say read on example. And no other user can execute or any other user can have any other permission. So let's say 3 blanks. I'm saying nothing for any other. So now let's do get FACL example. So you can see owner is user 1, group is user 1. User 1 has read write execute. User 2 has read write. Group has read write execute. Other has no permission. CD example. Example can change the directory. Let's exit or let's come back. Now let's log in as user 2. Although they are group member of the same sales group. User 2 and let's have an L. CD projects. User 2 can change to that because it's also the member of the same group where user 1 is of. Examples directory and let's have an L example. It can list the example directory, but can it change to example directory? Permission denied. Why? Because we have set up the read permission there. Sorry, it's a get FACL. So now you can see, because user2 can only read. So to change directory, I also need execute permission. This way I can have much finer control over permissions, although the users might be part of the same group. So this is what we saw. So we looked into the Linux file system permissions. We looked into Linux ACLs, and we looked at some of the examples on ACLs.